Hello, my name is Antonio Meléndez, and today I'm going to talk to you about arithmetic sequences. An arithmetic sequence is when terms change at a common difference in a series of numbers. In this example right here, we have a small series of numbers with four terms, 2, 4, 6, and 8. The first term is 2, which is a sub 1. The second term is 4, which is a sub 2. The third term is 6, which is a sub 3, and the fourth term is 8, which is a sub 4. In a formula, when we have the letters an, that means it's any term in the series. When we have an minus 1, it's the previous term in the series. And when we have a d value, that means it's the common difference, or the amount increased after every term. Our first formula of the day is the arithmetic explicit formula, and it's to find any term on an arithmetic sequence. It goes like this. A sub n equals a sub 1 plus d times n minus 1. In this example, we have four terms: 27, 44, 61, and 78. Our first step is to find the d value. It's pretty simple to find the d value. You just subtract 78 minus 61, 61 minus 44, and 44 minus 27. So let's do it. 78 minus 61 is 17. 61 minus 44 is 17. And 44 minus 27 is 17. Now we know that our d value is 17. All we need to do now is plug in. Our first term is 27. Our d value is 17. And since we need to find the 21st term, we need to multiply it by 21 minus 1. Now we just solve. Let's start off by doing 27 plus 17. 27 plus 17 is 44. And 21 minus 1 is 20. Now we need to multiply 44 times 20, and that equals 880. And it's that easy. By plugging in the correct numbers, you can find any term on any arithmetic sequence. Our second formula is the arithmetic recursive formula, and it's to find the d value when you're not given one. There are two formulas for this. The first one is a sub n equals a sub n minus 1 plus d, or a sub n equals a sub 1 plus d times n minus 1. Here we have an example of an arithmetic sequence where you cannot see the d value. What we need to do here is plug everything in and solve for d. So here it goes. I'm gonna use the second equation. Feel free to use the first one if you like. So the an is negative 44 equals 48, which is a sub 1, plus d times, and we have 5 terms in here, so we're gonna do times 5 minus 1. So let's get solving. So as you know, in here first we do minus 48 and minus 48 here. And negative 44 minus 48 equals negative 92. Now we have negative 92 equals d times 4. And here we just divide by 4 and divide by 4. And negative 92 divided by 4 equals negative 23. And here we have it. D equals negative 23. And now if we want to, we can fill in the blanks and replace these blank spots for actual numbers now that we know the d value. So 48 minus 23 is 25. 25 minus 23 is 2. And 2 minus 23 equals negative 21. So now we filled in the arithmetic series, and yeah, that's basically it. Our third and final arithmetic sequence formula is the sum of a partial series. It's where you find the combined number of any partial series. There are two ways you can do this. The first one is the rainbow trick. I really like doing this one because it's very fun to do and it's a great way to start learning. Here's an example. Here we have 8 terms, all the way from 7 to 14. And the way you do the rainbow trick is you add from one end of the series to the other. From one end to the other. And so on. Then you, as I said before, you add them and you get 7 plus 14 is 21, 8 plus 13, 21, 9 plus 12, 21, 10 plus 11, 21. And here you add 21 4 times, or 4 times 21, which is 84. And that's it. That's how you get the sum of all numbers using the rainbow trick. But although it's very easy to do, most times you're gonna do sum of all numbers, you're gonna have to use this formula. It's Sn equals n over 2 times a sub 1 plus a sub n. Here we have a slightly harder but still easy example of an arithmetic series. It has 7 terms, and I'm gonna find the sum of all numbers by using the equation. So let's plug everything in. Sn equals n over 2. The n stands for the amount of terms, which is 7, over 2 times a sub 1, which is the first term, 16, plus a sub n, which is the last term, 202. Now, we solve everything. Sn equals 3.5 times 218. We multiply these two and we get 763. Thank you so much for watching. I hope you enjoyed the video, and I really do hope you learned about arithmetic sequences.